Hello viewers, in this video we are going to discuss the nomenclature of bicyclic compounds, basically bicyclic alkanes. So bicyclic compounds are where we have two rings connected to one another. If you look at this one, it has only one ring composed of 6 carbons. So this is cyclohexane. But in this one, we have two rings. So this is a bicyclic compound. In the outer ring, like the main ring, there are 6 carbons, and this is the bridge which connects these two carbons, right? So we have total of 7 carbons. So 1, 2, 3, 4, 5, 6 and 7. So these two are equivalent. So this can be written as this one. Both represent the same molecule, right? Now we have to learn some terminology in order to name the compounds. These 2 points, these are called bridgeheads, right? These are called bridgeheads, and there are, if you look into this molecule, there are 3 bridges connecting these 2 bridgeheads. One bridge is this one, which involves 2 carbons, because these 2 are bridgeheads and the bridge contains 2 carbons. If you look at this one, this bridge also contains 2 carbons, right? And if you look at this bridge, this contains 1 carbon, right? So how do we name this? First thing we write is bicyclo, right? Because there are 2 rings in it. And then in the square bracket or the parenthesis, we write the number of carbons in a particular bridge. And those numbers have to be written in decreasing order or descending order. The largest number at the first, followed by second largest and the smallest. So you have in this bridge, you have 2 carbons. In this bridge, you have 2 carbons. And in this bridge, you have 1 carbon. You need not to count these 2 carbons. These are the bridge heads, right? So how would we write? We will write 2, 2, 1. Okay? And they're not separated by commas. They're separated by dots, right? Bicyclo, in the parenthesis, you write down the number of the carbons involved in a bridge, and the order of those numbers should be decreasing order, and are followed by the total number of carbons in this system, which is 7. So we'll write heptane, bicyclo 2,2,1 heptane. This is how you name it, right? Now let's do one more example. So here, if you look carefully, these 2 are the bridge heads. These are the bridge heads, right? So bridge heads. So there's a G here, right? So these 2 are the bridge heads. And how many bridges are connecting them? 1 bridge, 2 bridge, and the 3rd bridge. Okay? So the longest bridge is from here to here to here. How many carbons are involved in it? This is the bridge head. So 1, 2, 3. 3 carbons are involved on one side. Then in the second bridge head, 1 carbon is involved. In this bridge head, again 1 carbon is involved. So it would be bicyclo 3, 1, 1. And how many carbons? So if you look at this, this is basically 6 carbons like this. And then this is the 7th one. So it is again heptane. So bicyclo 3,1,1 heptane. That's the name of this compound, right? So if someone asks, are these 2 compounds the same? No, they're not the same. They are bicyclic, yes. They do have 7 carbons in them, yes. There are no substituents, yes. But the number of carbons in the bridges, they are different. So that's why they're different molecules, right? Now, coming to the 3rd example, these 2 points represents the bridge heads, fine. Now, once you selected the bridge head, we have to see how many carbons are there in each bridge. So if I go from here to here, this is one bridge, one carbon is involved. From here, 1, 2, 3. So 3 carbons are involved. And from here to here, from this side, 1, 2. So 3 on this side, 1 on that side, 2 on this side. So this would be bicyclo 3, 2, 1. And how many carbons are there in total? In total, we have, say, 1, 2, 3. Now, how to do the numbering? Yeah, that's very important. So when you're doing the numbering, always start the numbering from the bridgehead. That is the first point. Start the numbering from the bridgehead. And then which side to go? If this is my number 1, should I go this side? Should I go that side? That is decided by the longest chain, the longest bridge, sorry. So the longest bridge is on this side because it involves 3 carbons. So we'll start numbering onto that side. 1, 2, 3, 4, 5, 6, 7, 8. We went to 6 on this side, not to this side, because this bridge contains 2 carbons. So we have to follow this one first, like as the second one. This is the first bridge. This should be the second bridge. Why? Because this involves 2 carbons while this bridge involves the only 1 carbon. So we have to do the numbering in a way, start from one bridgehead, begin numbering the longest path, okay, followed by the second longest path, then finally the shortest path, right? So what should be the name for this? It has 8 carbons, so it would be octane. And if you look carefully at 8th carbon, you have the methyl group. What do you have? You have the methyl groups. So it would be, substituents are written in the front, 8-methyl bicyclo 3,2,1 octane. A question may come to your mind, like this time what we did is we did the numbering from this side to that side. What if I start doing the numbering starting from this? If I choose this bridge head as number 1, so which side I should go? I would definitely go to the right side because that is the longest bridge. So 1, 2, 3, 4, 5. Now where should I go? Should I go to the top or should I go towards the left? I would go toward the left because that is the next longest bridge, 6, 7 and 8. So either way, if I go that way or this way, my methyl substituent is, the carbon to which the methyl substituent is connected is getting the 8 number, and the bridge heads are getting 1 and 5 numbers, so it doesn't matter in this particular case, okay? Otherwise, the rule says that we should go with the longest bridge, followed by the second longest, followed by the shortest, and we have to do all this so that the substituent should get the least number possible, right? We'll see that in the next example. Example 4. So we have this molecule. I have numbered, once I started from this bridgehead, next time I started from this bridgehead. You see, I'm giving these two are bridgeheads, right? So once I started with this one, in the other one I started with this one, okay? And in both the cases, if I say how many carbons are there in the bridge, the first bridge has 2 carbons, this bridge 2 has 2 carbons, okay, and 1, 2, this bridge 2 has 2 carbons, okay? So we can go on either side, right? We can go on either side, and so I followed this one, I followed this one, then here I followed this one, right? If you look in this case, if I am going with this one, my methyl substituents are getting second number, okay, 2,2-dimethyl. If I go by this one, my methyl substituent is getting number 8, okay? And there's another way also. if I go by, suppose I can number them like this as well. 1, 2, 3, 4, 5, 6, 6. Then I have to cross that. So we'll go with this one. Okay. So here we are 3, and then we're going to 4, 5, 6, 7, 8, and all that. So the name of this compound would be, we'll prefer this one. Why? Because the methyl substituents are getting number 2. Here they are getting number 8. The rule says that we should have the least number for the substituents when we are following the things. When we are following the first rule, that is the longest bridge followed by this. So the name of this molecule would be 2,2-dimethyl bicyclo 2,2,2-octane, right? So this is the name of the molecule, right? And can you try this one? So if you look at this, which one is the bridge head? These two are the bridge heads. Okay, bridges, longest bridges, 1, 2, 3, 4, right? These are just, I'm counting the number of bridges, I'm not numbering them. So these are the bridge heads. This is one bridge, this is another bridge which contains 1 carbon, and the third one has 0 carbons in it. So we will write bicyclo 1, 2, 3, 4, right? 4, 1, 0, right? And how many carbons are there in total? 7. So heptane. Bicyclo 410 heptane. 0 is because these two bridge heads are connected with 0 carbon. There is no carbon in between. So that's why we are writing it like this, right? So on similar lines, you can try this one. And let me know in the comments if you are able to do that or not. Or you can try this one as well. Can put a methyl there and then try that one and answer these in the comments.